Hi, I'm JPonta.
And I'm David Lott.
And I'm Rhys Craiggs, and we're going to be showing you aspects of a petrol fuel system.
Today we will be showing you the aspects of an EFI fuel injected Hyundai XL, which is a multi-point fuel injected system. The following components are airflow sensor, throttle position sensor, a coolant temperature sensor, a crank angle sensor, an oxygen sensor, and also a cam position sensor. All these sensors are relevant to the vehicle operating in an efficient manner. Safety is something you should never ignore, because when you aren't being safe is when you usually get caught. Now first of all, there are some important safety aspects you must follow when repairing a fuel system. First, you will need the correct fire extinguisher handy. Be sure to release the fuel pressure and clamp off lines, and always make sure you're wearing safety glasses.
Common rail diesel systems may look similar, but run at a slight difference to the petrol direct injection, such as the common rail runs at about 29,000 psi, where the direct injection high pressure pump is 725 to 1,740 psi. The low pressure pump is 43.5 to 72.5 psi. Another difference is the direct injection has a pressure control valve and runs very lean, producing nitrogen oxides, or NOx.
The difference between a single point fuel injection system and a multi-point fuel injection system is that multi-point fuel injection systems have a separate injector to inject fuel directly through the intake valve port at each individual cylinder. The most efficient system is the multi-point injection system, as the air-fuel mixture won't be affected by flow losses in having to travel through an intake manifold. This improves engine response, reduced fuel consumption, immediate acceleration response, and lower exhaust emissions. Stoichiometric ratio is the term used to describe the chemically correct air-fuel ratio needed to achieve complete combustion of the fuel. This optimal ratio is 14.7 to 1. This is also referred to as lambda 1. This air-fuel ratio is critical to ensure the engine is running as efficiently as it can. This is usually achieved in a modern EFI system by having an ECU collecting signals from sensors located at certain points. For example, starting an engine from cold, an engine coolant temperature sensor would send a signal to the ECU that the air-fuel ratio needs to be a little richer to have more fuel than air.
Hello, some effects that happen when false air, or known as unmetered air, is the engine will run rough or may be hard to start, and it will be delivering the wrong amount of fuel. These effects happen because air measurements usually take place near the air filter, and the air being sucked in after that will make the air measurements incorrect and the mixture will become lean. As a better thought, man created something called a MAP sensor, or manifold absolute pressure sensor. MAP sensors provide instant information to the ECU. This calculates the air mass flow rate to tell how much air is inside the manifold, preventing major effects and to just cause revs to increase.
Here we've connected a fuel pressure gauge and flow meter to a vehicle to show how to measure fuel pressure rate. With this vehicle model, the workshop manual states that the fuel pressure should be around 250 kPa. Here with the engine running, you've got your fuel pressure, which is around the 250 kPa mark, which is a specification for this vehicle. And the bottom here you've got a fuel flow rate in litres per minute.
Hello, here we have it's a fuel pressure regulator. This little fella works by using a diaphragm and a spring combination in its housing. A vacuum source is on the top side of the diaphragm to counteract with spring pressure when the demand for high fuel pressure is required.
A heated oxygen sensor has an internal heater circuit that brings the sensor up to operating temperature more quickly than an unheated sensor. An oxygen sensor must be about 600 to 650 degrees Fahrenheit before it will generate a voltage signal. This is a quick demonstration on how you can test an OT sensor. They can be tested both in the cart and out if you have a high independent voltmeter. The engine must first be fully warm. If you have a defective thermostat, this test may not be possible due to the minimum temperature required for closed loop operation. Attach the positive lead to a high independence voltmeter to oxygen sensor output wire. This wire should remain attached to the computer. You will have to back probe the connection or use a jump wire to get access. The negative lead should be attached to a good clean ground. The procedure is fairly simple, but it will help you to have some background knowledge on the way a sensor does its job. The throttle sensor responds to the accelerator pedal movement. This sensor is similar to a potentiometer, which performs the throttle valve position into output voltage and emits the voltage signal to the ECU. In addition, the sensor detects the opening and closing speed of the throttle valve and feeds the voltage signal to the ECU. If the throttle sensor is removed or replaced, it is necessary to install in proper position. Install throttle sensor body in the chamber. Do not tighten bolts, leave bolts loose. Connect the throttle sensor harness connector. Start engine and warm up sufficiently. Measure output voltage of throttle sensor using voltmeter. Adjusting by rotating throttle sensor body so that the output voltage is 0.45 to 0.55 volts. Tighten mounting nuts. Disconnect throttle sensor harness for a few seconds and then reconnect it.
Crank position and cam position sensors send information to the ECU about the speed of the components, position of these components, and also the change in speed of these components. These sensors are usually of the pickup coil type. These types of sensors consist of a permanent magnet, yoke and coil. The sensor is mounted close to the toothed gear. When each tooth moves by the sensor, an AC voltage pulse is induced in the coil. Each tooth produces a pulse. As the gear rotates faster, more pulses are produced, and the ECU works out the speed of the component is turning by the number of pulses every second.
I'm going to briefly show you how to use a scan tool to find faults on an EFI fuel system. First, you'll need to press 1 to scan. Select your plug. Select your ECM address. There's a list of functions where you can do many tests and checks. We're going to check the DTC. There are no codes showing that the EFI system is ineffective, but there could be a physical fault still present.